Hello, now we are going to discuss about ripple counter. That is the type of the asynchronous counter. Asynchronous counter means the clock pulse is applied only to the leftmost flip-flop and remaining flip-flops are being triggered by the output of the previous flip-flop. If you see in this case, if you mark this one as the flip-flop 1, or like in case of digital, we start the counting from 0. So this will mark as the flip-flop 0. This one will mark as the flip-flop 1. This is the 2 and this is the 3. So now here, if you see the construction part, only 0th flip-flop is given clock pulse. That is given here count. And output of the previous flip-flop, that is output of 0th flip-flop, that is D flip-flop. Here if you see that A0 is going to be the clock pulse for the next flip-flop. So that means the output of the previous flip-flop is going to trigger the next flip-flop. Like this, successive stage takes place. And here if you observe that at the clock pulse, bubble is applied. Bubble is applied means this is flip-flop is being triggered when there is a transition takes place from 1 to 0. So whenever there will be transition from 1 to 0, then only flip-flop is going to be triggered. On the basis of this, here, whenever this A0 is going to change from A to 0, then only it will trigger A1. A1 is the output of the next flip-flop. Again, when A1 will change, here which one was changing? A0 was changing 1 to 0. And again, when A1 is going to change from 1 to 0, then it will trigger A2. Further again, when A2 will change from 1 to 0, is going to trigger the A3. If it is changing from the 0 to 1, then it will not trigger. So that we have to keep in mind that on the basis of which later discussion will take place. So whenever we have change from 1 to 0, these outputs are going to change from 1 to 0, then only it is capable to trigger the successive flip-flop. So here if you see that name itself is that ripple. So like suppose for example, in a water if you are going to put one stone, it will create a small circle. This circle will create again big one. Like this successive ripples takes place. So same way here, output of one flip-flop is going to trigger the next flip-flop and name is the counter, so it's provide the counters. So here on the basis of the connections, it will do the counting in the ascending orders and on the basis of different connection, it's going to provide the counting in the descending order. So here, whatever connection is given here, if you see that Q, this output is the Q, then this one is the Q bar. So Q bar of which flip-flop is given back input to the D flip-flop. So for all flip-flops, we have similar connection. And here A0, that is the output of the previous flip-flop, is given as the clock pulse. So where symbol is bubbles here. So here we have concept that whenever transition will takes place from 1 to 0, then only it is going to trigger the successive flip-flops or then only change going to takes place. Whenever it will change from 1 to 0, then only change will takes place in the successive outputs. Why I am repeating this one again and again? On the basis of this entire discussion is going to take place, how shifting will takes place. Okay. And you know already about D flip-flop that it is the transparent flip-flop. So whatever input you are going to give, that is going to appear at the output. So now here, if you see that in the initial stage, all outputs are 0. A0, A1, A2, A3 all are 0. Now what is going to happen? When here negative edge triggering takes place for the zeroth flip-flop here, then here we'll get some output. So what will be that output here? Since initial is here 0, suppose for example, A0 is 0 means this Q bar will be here 1. This 1 is given back here again as the input, and finally then A0 is going to be 1. So for each negative edge triggering clock pulse, that A0 is going to change. So that A0 is going to give the complement output every time. So that you can observe here that A0 is changing to 1, again it's changing to 8120, again 0 to 1. So for each clock pulse, it has changed. Or this one also we can keep in mind that to the power 0 is 1. So for every clock pulse, there will be change in the A0. And here to the power, since I'm using this suffix, so to the power 1, that is the 2. So for every, after 2 clock pulse, there will be change here in the A1. And again here to the power 2 is 4. So for after 4 clock pulse, there will be change in the A2, and here to the power 3 is the 8. So after 8th clock pulse, there will be change in the A3. Before that, change will not occur. So to understand it in the better way, we can take one small examples. So on the basis of that, we can see how it is going to be changed. Now whatever connection is given here, that's going to perform the up counter. Or this one also we can call as binary ripple counters. So it's going to count the binary numbers in the ascending order here. Now suppose for example we are taking at any stage we have output 0 0 1 1. Now from here in case of up counter, how we are going to obtain 0 1 0 0. Since this decimal equivalent is 3, so how we'll get the 4? So that we are going to see here with the our concept. Now concept is that whenever it will change from 1 to 0, then only it can complement others. So here now this is our A0, this is the A1, this is the A2, and this is the A3. So now first what we have 0 0 1 1. Now this 1 is going to change to 0. So what we get here 0 0 1 0. So since this has changed from here 1 to 0, so that means it will complement going to complement the next bit. So due to that, now this bit will be complemented. So what we get there 0 0 0 0. Now again what we are seeing that this one has changed from 1 to 0. That means it will complement the next one. So that's why we get here 0 1 0 0. So finally, this one is being complemented. So now if you see here, now it has changed from the 0 to 1. So that's why it's not going to complement the next bit. So now here it will stop. So finally, from 3, we are able to get the 0 here. So whenever it will change from the 1 to 0, then only it can complement the next bit. Like here, it has changed from 1 to 0. That's why it have capability to complement the next bits. So that next bit here A1 is complemented to 0. Again, it has complemented 1 to 0. So again, it has capability to complement the next bit. So A2 is also complemented. But A2 has changed from 0 to 1. So it doesn't have capability to complement the next bit, that is the A3. So like this, we are able to obtain this counting in the ascending orders. Like this, you can take example and you can practice the any other combinations where you have to keep in mind that whenever it has transition from 1 to 0, then only complement will takes place. Now, if you see that how this connections, if you make some change here, how it will act as the down counters. So here if you see that in case of up counters, here we have 4 bits. So with the help of 4 flip-flops here we have designed. So to the power 4 is what? 16. So it has capability to count from the 0 to 15. So it will go up to 0 to 15. Again, it will reset and again it will start from the 0. So that's why you see here that reset connection is also given here. So this counting will be from 0 to 15. Again, it will back to 0. Again, it will start the counting. Whereas when we'll talk about the down counters, then there will be change in the connection. Here we have to use the positive edge triggered clock pulse. Positive edge triggered clock pulse means whenever it has transition from the 0 to 1, then only it is going to trigger the flip-flop. Similarly here, if output is also going to change from the 0 to 1, then only it can trigger the successive flip-flops. So that concept is reverse here. So here whatever clock pulse will apply, that clock pulse will be applied here. That symbol will come without bubbles. Here also it will come without bubbles. Here also will come without the bubbles. Since transition is going to take place 0 to 1, then only it has capability to trigger the next successive flip-flops. On the basis of this, we'll see that how we can get the output as per the requirements in the descending order. Now suppose for example, we are taking the same example 0, 0, 1, 1. From this, if it will go in the descending order count, we should get 0, 0, 1, 0. So that we are going to see in this condition. So we have first 0, 0, 1, 1. Now this 1 is going to be complemented. Since you have seen that for after getting each clock pulse, A naught is being complemented. This is the A naught, this is A1, this is A2, and this one is the A3. So now A naught will be complemented. So what we get here? 0, 0, 1, 0. Now here it has transition. It has changed to 0. But what is the transition here? It has changed from 1 to 0. Since your transition takes place 1 to 0, now it doesn't have capability to trigger these successive flip-flops. So that's why output will remain here 0, 0, 1, 0. Now again, if you see that here again that situation will come further that you can get from this 0, 0, 1, 0, we'll obtain the output again as the 0, 0, 1. Now suppose what will happen here next stage. Again, if you talk from 0, 0, 1, 0 here. So now this 0, that is the A0, is going to change again. So now it will change to 1. So we'll have here be in between 0, 0, 1. And this is going to change to 1 here. So now if you see that it has changed from 0 to 1. So that is the positive edge triggering. So it has capability to change the next flip-flops outputs. So finally, now this A1 will change. So we'll get here 0, 0, 0, 1. Now again it has changed from the 1 to 0. So whenever it is changing 1 to 0 means it doesn't have capability to change the next flip-flop. So we'll get again 0, 0, 1. Like this, in the descending order, it will count from the 15 to 0. After that, again, it will reset and again it will start counting in the descending order from the 15 to 0, where it will called as the down counters. Like this, we have discussion. So finally, what is our conclusion from here? What is our finding from here? When if you have connection like this, and if it is going to in this connection, almost always it will work as the up counters. So for this, what is the logic? Here we are going to use negative age triggering concept. Negative age trigger. That means whenever it has changed from 1 to 0, then it will change the successive flip-flops in case of up counters. Whereas in case of when it will act as the down counters, all clock pulse will change. These bubbles will not be there. Then transition will take place whenever it is going to change from the 0 to 1. 0 to 1. Okay. In that case only, it has capability to trigger this successive flip-flops. So here we have concept of positive age trigger. So like this ripple counters or binary ripple counter is going to work, which is the one of the example of asynchronous counter. Thank you. Thank you.